Okay, so this is a project by Martin Kleppmann, who did very interesting presentation about isolation level. And in this project, he tests the different databases, the different isolation levels for different databases. For example, this is where you can see that Oracle doesn't really support serializable, only snapshot isolation, even if they call it serializable. And of course, there is Postgres, and my goal here is to test the same for YugabyteDB. So first, I will start a database. I think I have a Docker line to do that there. For the moment, to enable read committed, you need to set the flag enable read committed isolation to true. It's not the default because it is a recent feature, and for rolling upgrades, you don't want a different behavior in all nodes. So here I've started a single node YugabyteDB for this test. I don't need something with multiple nodes. I think it should come up there. System check, starting. I have my cluster there, no tables for the moment. I will clone the repository from there in my home directory. Hermitage. And I will copy the Postgres one to YugabyteDB.md. I see that Cockroach has added this for them, but they support only serializable. Let me check their result. Yeah, Cockroach is not Postgres compatible in this sense, where supports only serializable, where Postgres is by default read committed. The star means by default. And then most of the Postgres application is running in read committed. I'm connecting to my local cluster with 2 sessions. And I will test YugabyteDB. I'm in 2.13.1. It's not the latest version, but I will test it again with the latest version. I think everything is there in this version. Let me quickly change that. I will start the cluster again. With the latest version. Where is it? I don't know. Yeah, the latest preview is there. So that will be .2. Just checking where Postgres is mentioned, and everywhere I will update. with Yugabyte. Sorry, this is already started. I connect and first test. First, creating the table. Test table. I can see it. If I refresh there. So I think it doesn't matter here. By default, the first column is hashed for better distribution. Should be okay for this very simple test. I could have created it in multiple tablets, but we don't really need that for the moment. Okay, so checking the current isolation level, the default is read committed. That's Postgres compatibility. I mean, the default isolation level at Postgres level in YugabyteDB is always read committed. But the new feature that read committed really behaves as read committed instead of repeatable read is enabled with the flag I've enabled before. So starting transaction on each one. In the first session, I update ID1. In the second session, I update ID1 also. This blocks, same as the Postgres behavior. In the first session, I update another row. And I commit. This unblocks the second session. So this is true. And if I check the values in T1, I will reduce the size to see that. Where was my select? Start from test. Yeah, so I committed, and in session 1, I selected, shows 11 for 1, 21 for 2, perfect. In T2, I update ID2. Was there. In T2, I update ID2 and I commit. So I'm in T2. I commit. And I select from both sessions. And I see, of course, the same shows 12 for 1, 22. Yeah. So this is fine. YugabyteDB read committed prevent. Sorry, that was for the next one here. YugabyteDB prevents aborted reads. I think I have to set up, don't know exactly. Let me try. I will see if I have to set up the tables again or not. I don't really know. In T1, I update. In T2, I select. Okay. So the test is supposed to recreate the tables. For each test, which makes sense. I create it again. And we were on this one, huh? Yeah. Just reconnect it. And checking that. Yeah, this is what I think. I didn't insert. Okay. Now ready. Transaction 1. Begin transaction in read committed. Transaction 2. Begin. Oh, I was already in a transaction. Transaction 2. Begin read committed. Transaction 1. Update row 1 to 101. Transaction 2. I select. Still shows 10 for 1. That's isolation. And transaction 1 aborts. This means rollback, but if you want a real abort, then what transaction 2 shows, still the same. Yeah. So this was about Postgres read committed prevents aborted read. Same for YugabyteDB. Okay, next one. Drop, create, insert. Read committed prevents intermediate reads. Again, I start read committed transaction on each session. In T1, I update ID1. In T2, I select, and that still shows 10 for 1. In T1, I update row 1, and I can. In T2, no, sorry. In T1, I commit. In T2, I select and I see 11. This is read committed. The read snapshot is from the beginning of the statement. So what has been committed, even during my transaction, what has been committed elsewhere is now visible. So that's the correct behavior of read committed. And this is the same in YugabyteDB. Drop, create, insert. Let's see the next test. Read committed. on both. Update ID1 on session 1. Update ID2 on session 2. Select shows 20 for 1. Perfect. And here shows 10. Okay. We are able to commit that. Again, same behavior. Next one. Yeah, I'm anticipating, but let's do that. Sorry, drop, create, insert on T1, on T2, and I need a third session. Which is also with committed, of course. T1 updates row 1 and row 2. Okay. T2 updates row 1 and will block. Okay. T1 commits and this unblocks T2. Perfect. From T3, which has been started before all that, shows, sorry, I'm not connected to the right database, which means that I have to start everything again. Drop, create, insert. We were there, T1, T2, T3, T1 updating row 1 and row 2, T2 blocking when updating row 1, T1 commits, this unblocks, and then from T3 I see 11, perfect. On T2 I update ID2, on T3 I select ID2, I see 19, perfect. Now T2 commits, T3 sees 18, and for row 1, 12, perfect, commit. And this all works. The same in YugabyteDB. Next one. So T1, T2. I think I don't need T3 for there, so let me just reduce it. I start the transaction everywhere. T1 selects for value 30, returns nothing, yes. T2 inserts value 30 and commits, and then T1 returns this newly inserted row. This is the behavior of read committed. You can see those phantom reads. Same in Yugabyte. Okay. Next one. Starting repeatable reads now. So we are looking at repeatable reads, starting that I was in a transaction. Then I have to redo the DML. Okay. Starting that again, I need to take, okay. Repeatable reads. Oh. Set transaction isolation level must not be called in a sub-transaction. But that was okay before. Huh? I think we have a bug there. Let me try to begin isolation level repeatable reads. So this one works. And I am in repeatable reads. So I think we have a bug about the syntax. I'm just writing it here and I will open a Git issue. Okay, I had some problem with Markdown. So I have repeatable read transaction in 1 and 2. In 1, I select for 30, returns nothing. In 2, I insert this. So we are doing the same as before, except that in repeatable read, this still returns nothing because we read from a snapshot from the beginning of the transaction. Okay. So the behavior is the same. Only difference is some syntax is not correct there. Drop, create, insert. Starting. So this will be the same here. Huh? No, this is read committed, so perfect. This works. We are testing again on read committed, another anomaly. Update. And here the same row but with a different value passed. And this one in Postgres blocks. Read committed doesn't prevent predicate many procedures for write example. How is this possible? I think I will start it again because I think I forgot to insert. Drop table. Well, create, insert. Okay, I'm good. Read committed in 1. Read committed in 2. Update in 1. How can I have 0 row updated? Did I really insert? I didn't. Okay, understand what I did. I was just recalling the last command with an insert, but now I have one with a command. Okay, did the same error 2 times. Drop, create, and insert is not this one, but not this one. Insert values. Okay, now let's do that again. Starting transactions in both. Updating, I increase the value for all rows, so I have 2 updates. This works. And then doing a delete on those rows that are locked. So we wait for it. When session 1 commits, session 2 is unblocked, and since that Postgres is expected to return the row that has been deleted, read committed does not prevent predicate. But here this anomaly is prevented. This is really interesting. I am in read committed. Okay. We'll just do it again to be sure. Create, no, drop, create, insert values, okay, T1, T2, T1, T2, T1 commits, T2, okay. So I leave the Postgres behavior because it is different. Prevents this. Really, really cool. Next one. Drop, create, insert. So we are in repeatable read there. Let me just pause because I have a meeting with a colleague and I will postpone. I just pause the recording. Okay, the record is starting again. I just postpone a meeting with a colleague. So here I inserted, I have new sessions. I'm ready to test this one. And we have seen that the syntax for it, repeatable read, is better like this. Okay, now in T1, I update. If T2, so here we are testing the same thing as before, which was not working in Postgres with committed, which was working in Yugabyte with committed. So I expect the same. Okay. T1 shows an error, could not serialize access. Perfect. And then T2 has to abort. Yeah, I can commit because the other has been. Okay. So if this is the right behavior, let me check because I didn't really think about it. We are repeatable read. I update all rows. I delete for a specific value. From a snapshot from before this update, it waits. If I commit the first one, then all values are plus 10. Let me check what are the initial values. I forgot. I had values 10 and 20. So plus 10, I have values 20 and 30. The first one cannot commit because there were an intention to delete those rows. And it gives an error. What did we have before? Because I think it was a bug. This is the same. Update all values, blocks. Yugabyte returns no rows. So we were able to delete. But that was in read committed. And I think we had a restart. I want to see it again. So 10, 20. I update all. 20, 30. Okay. Now I am in read committed. So I take a snapshot from there, from what have been committed, but the first one is not committed. So I delete all value, and this blocks because I need to know if it is committed or not. And when it commits, I expect my session 2 to see the committed value, so 20 and 30. So let's commit it. I expect here to see 20 and 30 on this one. So yes, this unblocks T2 and 20 has been updated. Uh, 20 has been deleted and only this one remains. So this works, and I think this is the problem with read committed. I blocked about here. Where Postgres just ignores and reads the newest value, but the old one was already read. I will test it again because this can also depend on the order where the rows are read. And I am ordered on hashed. Yeah, but I can see the order here. Okay. I just test it with another order, just to be sure. Okay. Session 1 is read committed. Session 2 is read committed. Here I will do the same, plus 10 for all rows. Okay. And here the idea is that in Postgres, this reads the value 10 and deletes it. No, wait for it. Then session 1 commits, and then it reads value, the first row, which is now value 20. And because of the snapshot doesn't delete it. Let me do the same, but with the other one, which is, sorry, not in this session. 31st, but then we don't see the anomaly even in Postgres, I think. Just wanted to check that. Yeah, this one is not logged. Because I have only um, 10. Okay, so this waits on the first one now. So that's the difference. Commit. This is unblocked. And here, no row is deleted. Select star from test. And then I still see it. So I think it just depends on the order. Where the rows are read. And because I am hash sharded, may have a difference there. Let me try to drop tables test and create it as a range sharded table. To see which behavior I have with the default one. Okay, now running the same. T2 deletes, waits, T1 commits, and then T2 has deleted one. So we have the correct behavior. And I have to check if this depends on the order of rows. Okay. So with repeatable read, we have the same behavior. I have just a little doubt about read committed. I don't know if it is because of the different physical order of rows or if it is really because we process it differently. Now a case about lost updates in read committed. Yeah, because we read from another snapshot, so I expect here to be the same. Hope I didn't forget to insert. $20. So both sessions C 20, both updates it to 11. Second one waits. First one commits. And because we have no repeatable reads there, session 2 has overwritten the data. All commits, but to see it, yeah, this is not really how I would check that, because here we don't really see the overwritten. When you do a +1, for example, you can see that it is overwritten. I will do it to prove it. I'm not convinced by this test. Drop, create, insert. We start the same with the same selects on row 1. But now I will run an update where I set value equal value plus 100. So this session expects to put 110. This one is doing the same, expects to do 110. This one commits. For a syntax error, this is Postgres behavior. For a syntax error, I have to redo it, because I have no save point before the statement. But I will begin transaction read committed. Begin transaction read committed. Select. Okay. Update plus 100. Update plus 100. Commit. This unblocks there. select star from test. I have plus 100 for row 1. Select star from test. This one expects the same because he has read 10, added 100, but now I have 200. This is expected in read committed. Is this a lost update? Yeah. I tested something different. Sorry. The last update just said that the first session didn't see its initial update because it was overwritten by the other. So my second test is something different. If you want to see it, the first session should have to select it. Okay. I'm just thinking while doing it and testing other things. Drop. And I'm also a bit in a hurry because I have a meeting with a colleague. Repeatable read. In both sessions. Basically doing the same. Both read, both update, and then we will see the right behavior that the test was focused at. Just this one doesn't block this one just say operation fails. So here we have a difference. We do not block until commit. We immediately tell the user that something conflicts. So Postgres blocks, but YugabyteDB detects the conflicts immediately. Operation failed. Try again. Blah blah blah. Conflict with higher priority transaction. And when it is about transaction, it can also be the first one because they have both a priority at random within a range, and if you don't change the range, settings where name like YB something transaction something. YB transaction priority lower bound, upper bound, there are 0 and 1 for both, so I have one chance out of 2 that one fails or the other. We can change the bound if you want higher priority. So here the point is that, yeah, if I commit here, now this one, yeah, I disconnected. But this one would be able to. So here we have a small difference behavior. So YugabyteDB prevents the lost update. And detects it earlier. Okay, where are we? Read queue with read committed. Okay, this is read committed in T1, read committed in T2. Select for ID 1. Select for ID 1, of course, shows the same. Select for ID 2, that's 20. The second one updates to set value 12 for 1, 18 for 2, and commits. What happens here? 18, perfect. Same. So no read queue because we are in read committed, and then the first session sees the changes from the other even within the same transaction. From a transaction that started for T1 transaction that started before T2 changes, we still see T2 changes. And this is different in repeatable read. Preventing read skew, so same, drop, create, insert. Repeatable read. Repeatable read. I have 10 here. Yeah, doing the same as before, exactly the same, just with different isolation level. Reading 2 of them, updating the 2 of them, commit. Now we see 20. So this is just perfect Yugabyte. Wow, YugabyteDB. I didn't expect this to be so long. Drop, create, insert. I will go faster, I think, for those one. Repeatable read. Was just not sure. So I have repeatable read in both of them, okay? Reading with a modulo, updating, and now, because it was updated, first one sees nothing. This just works. Again, repeatable read. Select. Shows the 10. Select. Update to 12, update to 18. So we updated both rows, we commit. And now what if I want to delete here? This is a different error. A K conflict. But same. Next one. Write queue in repeatable read. Both session read, but different. Yeah, the two rows. Updating 1 in session 1. Updating 2 is session 2. Commit there. Commit there. So the fact that I've read them before doesn't change. We'll see serializable does different thing. Same with Yugabyte, and now with serializable. This is where we can prevent this anomaly. Drop table, create table, insert. Do I have the same error with serializable there? Yeah. Doing the same. The PSQL prompt shows me that I am in the transaction. So I have two sessions in serializable and doing the same, selecting both rows, updating. This is where I have an error. Again, it's detected before. In one or the other, depending on the priority. I will put better commands next time. Repeatable read. T1, T2. This is the first time I'm testing this, and this is also why it is not clear. This is not a presentation, just me recording my tests. It will deserve a presentation one day about isolation levels, for sure. So 30 and 42 returned in both. So same behavior in repeatable read, and I think we will run the same in serializable. Detected earlier. Wow. Last one. Because I postponed my meeting for half an hour, but I have to go. Going a bit fast there. But anyway, I will put comments in this document. Serializable. Serializable. Okay, this is not exactly what we wanted. This is the problem. When we want to go fast, we go too fast. Serializable. And session 1 shows 1020. Okay, serializable. 1020. What? I've inserted silly things, probably. We are without reading my insert. This is the initial state. Serializable. Select 1020. Easy. Serializable. Okay. AI update ID2. And I commit. And now, in a third session, serializable. I select everything and I see 10 and 25. I commit to end my reading transaction there. And now in T1, if I want to update, this is where I have YugabyteDB error is Operation failed, unknown transaction. Could be recently aborted. So different way to detect it in a distributed database, but detected. And at the same time, it was the update. Okay. That's all. I will update this, test it again, get understanding about it, open a Git issue about the syntax, and probably have a pull request to add YugabyteDB in this awesome little repository. And we will see the same as Postgres for YugabyteDB. And this is why we say that we are Postgres compatible and that Cockroach is not Postgres compatible, of course, only protocol compatible. Okay, great. And this is not a presentation. I'm sorry. I did a lot of mistakes and retried and thinking, and but this is research, not a presentation.